Hello, welcome to implementing binary search trees in Python. Uh, this video I'm going to be going through the code and how to do it. I won't be touching too much on theory, but I'm going to show you. I'll just show you right now. I made this pretty dandy tree in Paint, and I'm just going to run through it real quick. I only got 4 numbers, and I already know where they're going. Uh, First thing you got to do, you have to have a root for the tree, and that's always the first number. Cancel it out. Next, we'll go to our next number 10. We always start from the root and then work our way down. And when our new node is smaller than the current node we're on, we move to the left. Otherwise, move to the right. So 10 is bigger than 5. We'll put a 10 right there. Now we're down to 2. We start back at the root. 2 is less than 5, so we put 5 or 2 right there. And last we have 6. 6 is bigger than 5, move to the right, and as you can guess, 6 is less than 10, so we throw it there. Pretty simple stuff. It runs in log n time, which is a lot better than like a linked list or array or anything like that. So once you're sorting large amounts of data, binary search trees are a better way to go if you're searching and deleting. But let's get into the code right now. So first thing we're going to need to do is get a node class. This is going to be like an object that we can keep reusing. So init. So every node has a left, and we'll initialize it to be empty, and it also has a right node, or a right child, and we'll do that empty, and needs a key too. Forgot to add that up here. So the key equals the key. And that's all we're going to do right now for the node. If you're doing anything more complicated, you'd add other variables that you may need, but we're just doing the simple example. So okay, let's get our binary search tree. Let's initialize it, and the root has to have a root, and we'll initialize that to be empty. So okay, so just for this video, I'm just going to do insertion. It's going to be a little long if I had search and delete. So just insert today. And this is building the tree. So when we insert, we have to, the key we're using. So this is like the number we're putting in. So okay, first we got to check if the root is none. If that's true, then we'll set root to equal, oh, I forgot to make the node, so we'll have to actually make a node object, obviously. Forgot to do that, and we'll initialize it with the key. Okay, so back here, so we'll set the root to be equal to the new node. Okay, and if it does have root, it's empty, then we're gonna start the actual algorithm. So a couple of things we're gonna need. When we're traversing it, we're gonna need a parent node. Let's just set that to be the root. And we're also gonna have an instance node, and that is gonna be the root as well. So what we're gonna do is keep running through it until we find an empty one. So we're either go left or right on each node, and when we get an empty one, then we're going to put our new node there. So while the instance node does not equal none, so when it is none, we're going to break out. We have a place to put it, and then we'll just put the node right there. Parent node equals, just update that. Okay, so here's the main part. If the key, this key, is less than instant node key, then we'll go to the left. How do we do that? Instant node equals instance node dot left. So now when the while loop runs again, the instant node is going to be the left. And then we're just going to go down. So it'll be the left, and then, well, the next time through the while loop, it's going to be this one. Hopefully that makes sense. Else, we're obviously going to have to set it to the right. Okay. So now, while this is done, why is this not? Okay, so now that we have an empty spot, our while loop's done, we'll find a place to put it. So if key is less than, so we're going to use the parent node this time because right now the instant node is null. Key, we'll set parent node dot left will be equal to the new node, and that's it. We've now successfully placed our new node there, but we gotta do the else. Parent node dot right will be equal to new node. Makes sense? Hopefully that makes sense. So let's see if it worked. Let's create a new object, BST. Insert, we'll do 5. I think we did 2, 10, and then 6. Run this. Okay, well, nothing showed because I didn't say anything would, so well, the other thing I gotta do is be able to traverse it. So let's get a print function, print in order, and what we're gonna do is recursively run through this and print it every time we get to the farthest one. So call this again, and we'll set the node to be node dot left. Well, first, obviously we gotta check if node does not equal none, then we'll run through it. So then we'll print node dot key, and then we'll go through the left, or the right, sorry. Hopefully this works. Didn't call it. And we're going to send in the root. And there it is. So it prints it out in an order. So it goes all the way left and then goes back up. So any chance it can go to the left, it does. So it's going to go left, nothing there. It's going to go to this one. There's something there on the left, so we'll go there and then print that and then go back. That's all it's doing. So it's a very easy way of sorting a large list. So maybe I'll do a huge one, like 5,000, and then I'll get randoms. Insert. I think there's like a rand int, because I'm just doing integers. So there it is, and I need a range 0 to a bunch. See if this works. So yeah, you can see it looks like it's all in order, and it looks like you got all the possible letters. So That's all I'm going to do for today. I'll have a part 2 coming soon with it that has searching and deleting. Hopefully I can get those both into one video, but until then, thanks for watching.